The second speaker will be the Minkang Cheng from Texas. Minkang is talking about the seasonal variations in the station ranging bias and tropospheric zenith delay in SLR.
Good morning. I'm Minkang Cheng from CS Texas, the USA. Today my talk is just want to ask a question, because we will compare the geode solution from the SLR and the geode solution from GPS-based global convention. There's difference. This problem is also addressed this many times, maybe more than 10 years. The people always consider or conclude that this is because this is SLR, because it depends on the SLR distribution. So I want to answer this question, because so many papers already published said, okay, because it's SLR global distribution. Let me ask this, I want to answer this question. We look at the rigid bias and the seasonal variation, impact on geoset variation. Really, if we will estimate the geoset compare with also ground field 5 by 5 from 5 to 7 satellite. Then we get the geoset solution. The reason why is if we, at that time, we fix rigid bias. The rigid bias is systematic or the piecewise fixed to a station. In this case, we estimate the geoset solution. So there is a difference between the GPS-based global convention. Then we estimate the rigid bias, the monthly, if we got the mass solution from a gravity field, and now with rigid bias for globally from 5 satellite, then the solution will compare to the GPS leveling. In addition, we say the seasonal tropospheric zenith delay as first the paper or the next paper we discuss this issue. This one? This one? Second one. Okay. Rigid model is SLR. We got the null point. They do some correction for atmospheric correction, CM correction, and they apply the piecewise rigid bias. And even for some station, we apply the time bias. Also, other correction. And after we fit orbit, create a reference orbit, we do some residual analysis after orbit fitting from phase by phase, station by station. Use this equation. Right? No. I don't know. Huh.
The bottom one is the laser, and then you have the other two on top of it.
This one, laser?
So yeah?
Then go back. How do I go back to previous page? Okay. This one is for atmospheric correction, the atmospheric troposphere denial and gradient is using it from data A is only caused by zenith denial from model. And with MPF is a model from the MET and the published 2002 and 2004, always this model applied. Then, next part is for gradient, is not a model, is a data processor or the orbit coverage. But to study this part, I think we estimate the data Z at the GA.GE. These are two parts. Then I will show you results. No. Next page. Okay. No. Okay. Now this is from Masonry graph tracker for August 25. I just give an example from FastLab. Okay, because according to our strategy for solution, gravity of the geoset solution, we use this equation, y is residual from their region for all satellite at all paths. And H is partial matrix, this partial matrix include the gravity, 5x5 gravity, geoset, and dynamic parameters such as CD or position of this one together to solve this one. So this is from the distribution is data distribution, quadratic distribution is well distributed for determine the gravity field, 5x5 at the geoset. Third one, yes. This is show you rigid bias estimate for the Yanagadi from negative 1 to negative 2. The above the P is from the negative 1. Bottom is from negative 2. So all of this is even without the estimated rigid bias, they will always go to the residual, go to a solution. Always singular withdrawal. Because here this is some for if you look at the time series, annual velocity about 2 millimeter, and for both settings for negative 1 year 2. Third one. Yeah, this is time bias estimate for this same state for negative 1 year 2. You say negative 2 is the bias mean is smaller compared to negative 1. Because today I will not discuss this time bias estimate. Third one. Next. Okay, I compare to the annual variation in the EAU from SLR at Grace. Okay, the first now Grace is we use 60 by 60 gravity field to compute the equivalent water height. All this up directly for station, for this station. At RTF 232 reported this, the estimated the E component or east component, north component and up crashing. The SR is we just can only estimate up this direction is the stage height. So the SR compared to the ITF 232 is a very good agreement. The Grace means only degree, we use degree 2 to 60. So the high degree effects not equal to degree 1. Probably for RTF 232 also equal to degree 1 variation. So this party only means around 50%. This is from high degree surface loading. Okay, second one. Now this shows you season variation is a rigid bias at the data ZE from several. You say this is blue one is rigid bias, just rigid bias only. The second one, read RB at the data there is simultaneously estimate rigid bias, then it's design at the gradient. This is, you say this is from blue ones, this is also absorbed all of the information from into the rigid bias. This read at the data there is separated for that one. This also shows you then it's denied at the rigid bias, some phase is different 170, the opposite phase. So if we estimate this one, then all of this, then it's denied information will go to the rigid bias, even without the separate. And because this is a granite, this part is effect very small, almost close to 0. So the more important is about the zenith deny. But the seasonal, okay, next page compared to the annual variation for this term. If the first one is rigid bias only. This is annual amplitude phase. You say it's 5.01. We estimate both together, zenith denied HG, then this equals this one. And also compared to all of the case, this is data Z, data G, data Z compared with the case 2 and the case 4. This means zenith denied can separate from state rigid bias. Yeah. The case 6 is up and we just stage height with zenith denied and HGZ part. This is, you say, this zenith denied become port 26. Okay, this is G, this is smaller. This means, okay, zenith denied is, this signal will go to the stage height. Even without the estimated zenith denied, as previously report said, okay, this is, you cannot ignore this part. If only estimate, if do not take care about this zenith denied, this part will affect your height determination. The basic calculation is this, okay, you can separate it from separate stage rigid bias, but cannot separate stage height if you estimate stage height without estimate rigid bias. Next page. Okay, this is José solution. You say that for the first case, SR with 2030, because we published a paper about it from SR. At that time, the stage rigid bias were fixed without the estimator. You say, so this amplitude for X amplitude is 2.7, RTF 2008, if RTF 2040 is 2.6. Then compared to the GPS only, this is 1.8. This is difference for gravity group. This is more important because we need to use degree one loading invert the mass balance for over the estimate. So this is we need to understand this problem. So you say SR GPS is if I estimate whole mission for 2002 to 2012, 21, still we cannot absorb the signal there. If I estimate monthly bias as well as a gravity solution 5 by 5 with geotheta all together. So this amplitude is compared to GPS. Compared to GPS, never. For both you have X, Y, Z coupolator. Particular X, Z coupolator come to 2.4. Because GPS inverse, global inversion is still Z coupolator, still big. The TA13 is just use a grace gravity solution with the ocean bottom pressure that gives us small amplitude, both for X, Y, and the Z coupolator. Next. So summary is a significant signal appear in the state rigid bias. This is as a kinematic because without the estimate rigid bias, the geoset solution is a dynamic effect from all stations. This part accounted for all the signal you go through without the estimate rigid bias. We will estimate the rigid bias as well as the geoset coupler. So this means the results can compare to GPS-based global conversion. This means from this approach, we can separate two signals. One signal is a rigid bias. Second one is a surface loading causes station change. Of course, how to interpret the seasonal signal is rigid bias. This is another talk. Today I tell. Second one, effect as the previous discussion. This effect of the this modeling of tropospheric 9, and this one must be take care for estimated seasonal displaced EU. That's it. Thank you very much.
Thank you very much, Minkang. One short or quick question will be allowed for the interest of time. Okay, if not, nobody online. Thank you very much, Minkang.